Give me your money. No, leave me alone.
Another classic homicide, and no cameras are around to see who did it. What's this? Let's bag this and send it to forensics to see what they can find.
The DNA sample is taken to forensics and they are able to create a DNA fingerprint through gel electrophoresis. 2 different loci are fingerprinted, so we have 2 profiles to examine. If we look at loci 1, we see that on the far left we have the crime scene followed by the victim and the 4 suspects. As we can see, the DNA cannot belong to the victim since neither of the 2 alleles match the sample. The difference in the location of the bands means the DNA pieces are of different lengths. Since the alleles don't match the sample from the crime scene, we can conclude the DNA sequences are different as they had to be cut by the restriction enzyme at different sites. We can also rule out suspect 1 for this same reason. Moving on to suspect 2, it looks like both the top and bottom bands match the sample from the crime scene, so we can't rule out suspect 2. It looks like suspect 3 has one allele that matches the sample, but the other does not, so it can't be suspect 3. And it looks like both alleles from suspect 4 match the alleles from the sample, so we can't rule them out either. It's important we look at another loci as well to confirm the information we have, because the information from just one loci doesn't seem to be enough. Looking at another loci might also help us narrow down the suspects even further. So we're going to do the same thing and look at each sample one at a time. It looks like the victim, again, doesn't match at any alleles. Suspect 1 has both alleles that match with the sample. Both of suspect 2's alleles also match the sample alleles. Suspect 3 has one allele that matches the sample, but the other does not, so we can rule out suspect 3. And suspect 4 has no alleles that match the sample from the crime scene, so we can also rule out suspect 4. Now let's look at the information from both loci that we just annotated side by side. From this, we can deduce which suspect matches the sample found at the crime scene, but we can gather other information as well. For example, we can conclude that suspect 1 and suspect 3 are parent and child. This is because they share an allele at both of the loci we examined. One of these individuals likely gave an allele to the other, and the second of the 2 alleles we see would be from the other parent. Although we know this, it is not possible to determine who is the parent and who is the child from the data we are provided. The only suspect who matches all of the alleles at both loci is suspect 2. Suspect 2 left their DNA behind at the crime scene.
I'm turning myself in. I can't take it anymore. She's haunting me. So what do we do the DNA fingerprinting for?